Hello, talking about type solvers today. Put together a new type solver and I've integrated some visualization into it, try to understand what's going on. So, this is just an example involving a generic type variable and some bounds negotiation. So, we've got a type, it's got an upper bound of listed of t. Listed is just a type that list extends from. Lists are immutable, and list builders extend from. List builders are mutable ways to produce lists. And we've got a couple type variables we care about. So the host for the type solver can introduce type variables. It's going to create variable names for things it cares about. And then after the type solver, it will have solutions for those. And so we've got tick x for the variable x, tick t for the variable t, which is in fact of type t, that bounded uh, type parameter. And then we've got list literal, which is the type for this empty list. So, we need to figure out what is it an actual list of. It's being kind of assigned to something in the same context. And so we've got a conditional assignment here. This if statement. It could be T or an empty list, and we want to come up with both with reasonable bounds for both of those. And so, yeah, we've set up our initial um, type relationships here. We've got here is it's moving around. I did not know. Here we've got a value bound for the empty list, and list literal is equal to that. List literal is assignable to x, so you see the subtype relationship there. Similarly, backtick t is assignable to backtick x, and we've got a declared bound for backtick t, which is t, and it's already been solved. It's this. And then the first time the type solver goes through its run, it's kind of explodes things out a little bit. It's going to realize that it needs a couple new variables. And so, based on the fact that the list bound, the value bound for the empty list is a list, it's going to say, it's going to synthesize its own bound. It's going to say this empty list is equal to list of some new variable that it's created. And yeah, this new variable is the list with this new variable is in fact equal to the type for the list of literal. We find that just by comparing, propagating bounds. And then we've, because the type solver needs to, be able to use its adjacency tables, we need to know that there's this kind of users relationship between the type variable embedded possibly very deep within a partial type. Um, and so we've got this users relationship. List of tick list t uses tick list t. Um, and yeah, so mostly this was just kind of this step through the type solver. It's just exploding things out and kind of synthesizing variables that it needs for its internal bookkeeping. But we have in fact kind of come up with and so we added some bounds, make it easier to propagate things. So there's now a bound here, and yeah. So now what's happened? We have in fact kind of computed more bounds. So um, you can see that what happened here is we compared list of tick list t to bounds on tick t. So comparing list of string to listed of string, we kind of walk up the supertype tree and realize that every list, every list of tick list t is in fact a listed of list, and then we can compare directly tick list t with string. And so, we get this listed of string here. We can, walk up the type here, and then we, project back through, and we get that, our list of tick list t is in fact a list of strings, and we've propagated that down here. So that's part of reconciliation when you're comparing subtypes in comparable ways and structurally walking these partial type trees to realize that, hey, we actually can infer from this a relationship between a type variable and some parameterization in the context of a common supertype. And so we actually have solved, we now know that this list literal is in fact a list of string. And then, yeah, we kind of did a little bit more bookkeeping and realized, that same thing for here. And I think, we still need to do a little bit more bookkeeping now. We've got solutions on both of these nodes that have an assignable to relationship with tick x. And on the next run through the solver loop, we actually do come up with a solution for that. So I think we've got solutions on all of our type variables now. And yeah, that's just a simple example of how kind of bounds tracking, reconciliation, and bounds propagation kind of work together, and yeah, works for fairly simple examples. I'm kind of working through some of the more complicated examples involving, call constraints where we've got a whole lot of different moving parts trying to get things ready for the type system and type inferencer that we're going to use in version 1. All right, thanks for listening.